Good morning, students. Today we'll start with the chapter 1, Chemical Reactions and Equations. In your daily life, you might have seen some changes that occur. For example, milk which is left at room temperature during summer, does it stay as it is? What about the iron, tawa, or the nail that is exposed to humid atmosphere? Grapes that are fermented, food that is cooked, food which gets digested in the body, and the respiration that is occurring in our body. What is happening in all these cases? The nature identity of initial substance has changed. So what has happened? A chemical reaction has occurred which has changed the initial substance. So if we have to define a chemical reaction, how will we define it? A chemical reaction is a process in which original substance lose or change their nature and identity and forms a new substance with different properties. This is going to be a 1-mark question for your examination. Now let us understand how a chemical reaction occurs with few examples. The first example is by burning a magnesium ribbon. Maybe when school starts, we can do this experiment in the class and see for ourselves. For now, let us see with the help of these pictures. First, you have burning of magnesium ribbon in air. What happens then if you take a strip of magnesium ribbon and then burn using a Bunsen burner? You can see a white powder. This white powder is nothing but your magnesium hydroxide. So this is the magnesium strip, and if you take this magnesium strip and burn using this Bunsen burner, you get a white dazzling light, and the residue is white powder. The white powder is nothing but your magnesium oxide. So what has happened here? The magnesium ribbon has burned in presence of oxygen to give magnesium oxide. Now let us take another example where we have taken zinc granules, and to this we can add either hydrochloric acid or sulfuric acid. So when you add the zinc granules to hydrochloric acid or sulfuric acid, what happens? Hydrogen gas is released. Since hydrogen gas is lighter, you can place an inverter test tube over here and collect the gas. Now let's see a video for the same experiment.
Hey everybody, we're going to demonstrate a single displacement reaction with zinc and hydrochloric acid. What you need is that you need a stand, test tube holder, a test tube that's going to be inverted, a funnel that we're actually going to use as an inverted funnel as well, and an Erlenmeyer. So the first step we need to do is that we're going to use some zinc metal, and what I have is just a little bit of zinc. We're going to pour a little bit into my Erlenmeyer flask. And that's good enough. And after that, I'm going to close my lid. And right now for this hydrochloric acid, I have a pre-diluted 3 molar solution of hydrochloric acid. So I think you want to use at least 3 molar or 6 molar. If you have more diluted versions of about 0.1 or 1 molar, you will still have a reaction, but it's really, really slow. So I would recommend at least a 3 molar. So I'm going to pour some of my hydrochloric acid in here, and once I'm done pouring, this is going to carry out a single displacement reaction, meaning that hydrogen gas is going to be produced. So after that, I'm going to put this inverted funnel in, put it into my test tube, and since hydrogen gas is lighter than air, it will actually go to the top and it will not sink down. Okay, and that's how we collect it. So right now I have the zinc in this Erlenmeyer flask, and all I need to do is to pour this hydrochloric acid in. So you might be wondering, how much of this hydrochloric acid do I need to put in? I would say about 40 to 50 milliliters. You just have to pour enough to have a reaction to produce that hydrogen gas from the single displacement reaction. So I'm just going to pour about here, and once I finish pouring, this is going to start bubbling because that's going to be our reaction. And I'm going to shake it a little bit, put my inverted funnel into my test tube, and keep shaking. And you can see that there is a lot of bubbles being produced. So I'm just going to let this reaction occur for a couple minutes just to get enough hydrogen gas into this test tube. So right now what's happening is that in single displacement reaction, the hydrogen gas is actually being produced, and it's going to go in and store in this test tube. Why it's storing in this test tube again is that because hydrogen gas is actually lighter than air, so it's not going to sink down. So it's going to be around here, it's not going to flow up because this test tube is going to capture it, and now we're just going to have to wait and to test the hydrogen gas. We're going to light a splint, and since hydrogen gas is flammable, when we put it in a lit splint into the test tube, we should hear a popping noise. Alright, after a couple minutes, you can see that the hydrogen gas is collected in the test tube. The test tube is a little bit cloudy, so we have to kind of light this on fire to test if there's hydrogen gas in the test tube. So here's my flame, we're going to put it in. Oh, so we can hear that little high pitch, and that's the presence of hydrogen gas being burned inside this test tube. And that's your single displacement reaction.
So heard the popping sound? Now, how do we determine whether chemical reaction has taken place or not? This is again going to be a 1-mark question for your examination. So you would see there is change in state, there may be change in color, there would be evolution of gas, or there might be change in temperature. Now, there is a large variety of chemical reaction taking place around us. Can you recall some? Maybe you could write answers for this question in your classwork place. I will be telling how to write your answers, or maybe you can figure out yourself. If you have any doubt, you can write to me. Now let's come to chemical equations. We have seen that chemical reaction happens, and when chemical reaction happens, there are some changes that occur. Now, writing chemical equations. Now, whatever the reaction that we have seen previously, we can write it as a word equation. So when we write it as word equation, it would be magnesium plus oxygen gives rise to magnesium oxide. So here the magnesium and oxygen are the reactants, and the product, that is magnesium oxide that is formed, is the product. So when you write a chemical reaction, on the left hand side you would have the reactants, and you would write a plus sign between them. This would be followed by an arrow pointing towards the direction of the product. The product may be one or more than one. Writing a chemical equation. Chemical equation is a shorter way for representing a chemical reaction. So chemical equations, why do we have to write them? To represent a chemical reaction in a concise form, we can use chemical equation. Now, for example, the same experiment that we have seen before, magnesium burning in air. Here, magnesium combines with oxygen to give magnesium oxide. So can you see this O2 here? What does this 2 represent? The subscript 2 represents the number of atoms, that is oxygen atoms, that are taking part in this reaction. So here you have 2, but in the products you do not have 2. So is this equation balanced? No, the equation is not balanced. So in the next session, we'll see how to balance chemical equations. Thank you.